They're of the form y equals a b to the x. Exponential equations have an x in the exponent, hence exponential equations. They have an x in the exponent. So we're going to do exponential and logarithms together. And then sinusoidal, you only have 3 units left. That's it. You'll be done before Christmas. When you come back after Christmas, I think like, I don't know, it's not very many days, and there's the English and Social Diploma. Like I think it's the week after you come back. Because we come back so late, right? I don't know, is it the week after or the week we come back? The week after? The English and Social Diplomas. Because I think we come back on the 9th or something, like silly late. We get off like 20, the 23rd. I think we're done. Is it the 23rd or the 22nd? Yeah, it's a Thursday. Yeah, we don't go to the Friday. Because it's so late. Okay. I'm glad we're recording this. So if anyone is wondering, English and Social Diplomas is the second week you come back. We are off on the 22nd is our last day. We have 23rd off. Y equals a b to the x. So we're going to look at equations where b is greater than 1. Okay? You're going to be typing stuff in your calculator. You're going to be looking at these bad boys. All right? Example 1. Y equals 2 and then 3 to the x. So our b is greater than 1. Our b is a 3. Our a is a 2. All right? Is that right? It's all right. Okay. Punch in your calculator. All right. Graph. Oh, goodness. Press Zoom 6 if your window's out to lunch. Like the sandwich. Okay. So, y equals 2, 3 to the x. What's my y-intercept? How do we find our y-intercept? Second trace value, 0. So it's 2. Or you can go second table and get 2. So the x-intercept, what's the x-intercept? The y-intercept is 2. What's the x-intercept? If we go to our table of values and we look at them, and I work this way, what does the e to the negative just mean? 0.000, the whole bunch, right? But this just means you're getting closer to 0 but not actually at 0. These ones will never actually reach 0, like ever. So there's no x-intercept. Because what you actually have is an asymptote on the x-intercept. So there are no x-intercepts. So if I drew this graph, if I just did a little sketchy sketch over here, and it's going to be a sketchy sketch, I'm going to have an asymptote on the x-axis, which is a dashed line. So that means you can't touch it, right? There's an asymptote on it. Now, if I plot some of the points on it, I can go second table, and this way again. Now, say you're stuck because you're someone who's pushing the button, seeing if it'll equal 0, because there's always one of you. You can go like this. You can go second, window, table set, and you can get the table to start at 1. So it plops you right back up there. And you don't have to do the, yeah, saves lives, saves lives. Okay, so -2, you can go to 0.2, and then -1 is at 0.6, so somewhere here. And then 0 is at 2. And then 1 is at 6. And that's good enough. So what your graph is actually doing is it has an arrow out here. It's running right above the x-axis, cutting through those points and going upwards. You always read graphs from left to right. So is this graph getting bigger as I'm going up from left to right or smaller? It's getting bigger. So this is actually an exponential growth. or it's called increasing. Now, what's my domain of this function? Right, because it goes all the way out here, and then this arrow is going outwards. It's just going out slowly, right? Out, but it's still going outwards. So the domain for an exponential is x and element of the reals. The range, anyone have any idea what you think it might be? Is there any part of the y below 0? No. So it's greater than 0. Is it equal to it? No, it can't be equal to it because we have a dashed line on it, right? So that's where everyone goes wrong. They put equal to. So it's going to be y such that y is greater than 0, yr, because the entire graph is above 0, right? Make sure your e's go in the direction of an e. Some people are doing them backwards. It's e for element, so make it be like an e. What happens if I... Okay, what happens if I keep the 2, but I change this 3, so I'm just going to put it below so I can see both of them drawn together. Say I go 2, and then I go 5 to the x. So I change my base to be a bigger. Like the base is the b value, I change it to be bigger. So it's going to draw the first, so the first one's drawn, and then the second one, it's getting steeper. Why would that be? Well, let's think about it. If I just look at a basic one, so I look at one where a is 1, and then b, this would mean a is 1, right? If I don't have an a value, it's 1. It can't be 0, because if it's 0, it will cancel the whole thing out. So if I filled in an x value into here, say I filled in a 2, then when x equaled 2, y would equal 4. So I would have the point at 2 and 4, correct? But say I looked at y equals 5 to the x. Then it would be at when x equals 2. It would be y equals 5 to the 2, which is 25. So my point at 2 would be at 25. So this one would be 2 and 4, this one would be 2 and 5. So it's going to grow faster, right? That's why it's steeper. Now what's my y-intercept on this one? Where x equals 0. It has the same y-intercept. What's great about 30-2 exponentials is that your y-intercept is always your a value. 30-1 is not the case because they do transformations on the graph, but you guys don't. So what you can remember is your a value is your y-intercept. And why would that be? Why would your a value be your y-intercept? Let's look at our equation. Y equals 2 and 2 to the x, or we had y equals 2 and 5 to the x. I don't know where I was going with that. When you're finding the y-intercept, what do you always plug in, Thotis? He is right. Follow what he says. Follow the toast. No. X equals 0. An answer is better than no answer. Okay. X equals 0. So if I fill that in, I'm going to get y equals 2 to the 0, or y equals 5 to the 0. What's anything to the power of 0? 0. Do I times these together and then raise it to the 0? No, this is only attached to this. Okay? So 2 to the 0 is 1. So that's why I get 2 times 1, which is 2. 5 to the 0 is also 1. So 2 times 1, which is 2. So as long as you just have the basic y equals a b to the x function, which is the only one you get, it's even on your formula sheet, a will always be your y-intercept, because when you plug in a 0, it goes away. Now what else have we decided? We've decided when you have the function y equals, this is like a little summary, a times b to the x, which is how it's written on your formula sheet. Right? and b is greater than 1, so we had a 2 or we had a 5, what we decided was the x-intercepts are what? On all those graphs, what was the x-intercepts? Where did it cross the x-axis? Nowhere, because I have an asymptote on the x-axis, right? So there are none. Okay. What's the y-intercept always? 0 and, in this form, what would it be? 0 and a. The graph is increasing. Or exponential growth. What's the domain? X and alpha the reals. What's the range? What's the range? It just would have been wrong. Okay? Yeah, true. Yeah. So what happens if we look when b is between 0 and 1? B can never be negative, by the way. Write that. B can never be negative or 0. That's not 0 factorial. That is a 0. B can never be negative or 0. So we looked at when, or 1, sorry. B can be never, or 1. B can never be 0, 1, or negative. So we looked at when b was greater than 1. We didn't look at when b was 1, right? We looked at when b was greater than 1. And now we're going to look at when b is between 0 and 1. But not inclusive of 0 and 1, right? Just between 0 and 1. So now we're going to look at when 0 is less than b is less than 1. So when it's between 0 and 1. So type into your calculator y equals 2 1/2 x. What happens to my graph? It's decreasing, which means that makes sense because whatever your value was, it's half of it now, right? Half of the value, half the value. So your graph is decreasing. Or called a decay. What's my y-intercept at? 2. It's still going to be at 2 because when I plug a 0 into here, a half, like to the exponent 0 is 1, right? Everything to the exponent 0 is 1. So my y-intercept is still going to be 2. So my y-intercept is still my a value. Now, what happens if I put this as a 3? My y-intercept is going to be 3. What happens if I do 3 to the 3/4? So 3/4 is actually bigger than a half, right? 3/4 of a cup compared to half cup. It is. So here's 3/4. It's going to get an error. What if I put in something less than half a cup, like 1/4 of a cup? steeper. Okay, what's my domain? X and the reals is still going outwards, right? Yeah, yeah. What's my range? Y is greater than 0, didn't change. What's my y-intercept? 3. Because that's not going to change, right? If I have a 3 here, it's still your A value. So let's write little sum ups for when the B value is between 0 and 1, when it's the function y equals A times B to the X. I write it as a times for dot. I don't like it as a times because it looks like an X. That's how it's on your formula sheet. Okay? So, how many X-intercepts do I have? What are my X-intercepts? None. Still didn't cross it. Ooh, something I can ask. What's my horizontal asymptote? Horizontal asymptote. It's the line that dashed line is at. Where does that line occur? It occurs on the x-axis, right? When something lies, you have a line that's constant, remember how we did polynomials? We had constant functions, and it was y equals 4, it'd be a horizontal line at 4, and y equals negative 3 was a horizontal line at negative 3. And we did y equals 0, and we said there was infinite number of x-intercepts at y equals 0, right? So we have a dashed line on the x-axis. So our dashed line is the asymptote. So where does that occur? At y equals 0. And for you guys, it's going to stay there, which is fantastic. The y-intercept is at 0 and A again. My domain, you said, was XER. Your range is y such that y is greater than 0. Okay. The corral. If you work, you will easily finish this in time.